Okay, so I've made a presentation and here it is. Okay, so this is called Discovery and How to Do It. Apologies if you know all this stuff, because some people haven't had the right education. There's two stages to discovery. There didn't used to be. Early philosophers only knew of one stage, the first part, conceptualizing. They thought their way to an answer. Then there was the Renaissance. And at that point, it was discovered that thinking doesn't actually produce a final conclusion. It has to be tested to see whether it matches the observations that can be made in the natural realm. So the second part of discovery is investigating. Let's take a look at conceptualizing. It happens inside heads. It may be based on what is known. Sometimes it is. Sometimes it's just a guess. It's an association of ideas. What you do in your head is you join dots. Okay? And the outcome is called an argument sometimes. People who think this way like to think they've come to a conclusion. I disagree. I would prefer to call the outcome of even the best logic an inference, because it's merely the outcome of conceptualizing, of thinking. And a subtotal is a good way of thinking about it. It's not the end of the story, it's halfway. So scientists would call this outcome a hypothesis. And hypotheses should be tested by investigating for matching observations in the natural realm, stage 2. If an inference can't be tested, and there are some like that, then it's not scientific. It's lesser than scientific. Now, investigating happens outside of heads in the natural realm. It's a search for observations that may confirm or deny a hypothesis, concept, proposition, argument, call it what you like. And of course, we want these investigations to be good, valid, verifiable, justifiable. So we try to conduct them under as controlled conditions as possible. We want it always to be the same environment. We want to be able to repeat it. We want large sample sizes. We want it to be double blind so that neither the investigator nor the subject knows which of the tests they are getting. And for example, if you want to measure the temperature of something, a changing temperature in whatever situation it is, then you want to maintain the same pressure. Otherwise, your results may be confused. You may be trying to measure 2 factors. We only want one. We want to eliminate other possible causes of the effect that we've discovered. Makes sense, doesn't it? And the investigations should be independently repeatable. You can do them yourself at different times, or in different locations, or using different detective equipment. But better than that is to get other investigators to do them, to see whether they get the same observations as you. Now, an investigation does lead to a conclusion. If the observations match the hypothesis is confirmed. If the observations do not match the hypothesis is denied. Those outcomes are both valid conclusions. Now, we need to understand the relevance of data and statistics in this situation. So, from the point of view of science, data is observations that can actually be measured. It's numbers, it's quantities, amounts. And if you get lots of them, a collection of data is called the results. Some effects cannot easily be measured yet. It's difficult to measure emotions, feelings, intuitions, revelations, or trustworthiness. These may be referred to as qualities rather than quantities. Statistics is a very useful tool for evaluating probabilities. That may be whether a proposition is likely and worth investigating, or whether some data is really a match for the prediction. It gives us degrees of confidence, not certainties. Statistics is a probability tool. So statistics can provide an empirical argument for a proposition, hypothesis, inference, whatever you're going to call it. And the best propositions, the most reasonable and persuasive hypotheses, are based on prior knowledge, which may be statistical. But no matter how logical, plausible, or probable, LPP, all hypotheses need testing for a match with observations. Remember, logical outcomes are just associations of ideas made inside craniums. Some hypotheses, arguments, outcomes of logical reasoning, conceptualizing, blah, 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 have been shown to be false in the past. Others have been confirmed by observations. Checking whether they match observations, checking whether a hypothesis matches observations, is how we tell a reasonable conceptualization from a false one. And if it can't be tested, a hypothesis, concept, inference is unscientific. In fact, we shouldn't call it a hypothesis because a hypothesis has to be based on prior knowledge from a scientific source. We are going to now investigate some examples. Okay. Example number 1, relativity. Einstein, he thought up the notion of relativity. It was sort of an armchair experiment with a pen and a piece of paper and lots of doodling of maths equations and so on. And he was doing this from the period 1905 to 1915. It caused a lot of interest, but only in the scientific community. However, it was not taken to be true until it was confirmed by observations. In this case, it was observations of starlight being bent by the sun's gravity well, which were made during an eclipse by Sir Arthur Eddington on an Atlantic island where the sky was clear for his telescope to be very effective, so he could make good measurements from the top of a mountain. And in that case, his observation matched Einstein's concept. So relativity was confirmed as a good model of reality. And it's happened many times. Subsequent investigations have also produced other observations that also confirm relativity. Therefore, it's no longer just a hypothesis. It's a confirmed theory. Right, example number 2. The Higgs boson. Peter Higgs, 1964, proposed an explanation, he thought it up, for why some particles have mass. His hypothesis required a heavy particle, scaled in particle terms, not physically heavy to us, but down there in the micro world, heavy relative to the rest. It's called a boson. Heavy particles are bosons, and this particular one was named after him. And once again, that model was not taken to be true, but it was thought to be worthy of investigation. As it was difficult to investigate because the Higgs boson is unstable and very short-lived. However, in 2012, after increasing the power of the Large Hadron Collider, a particle that matched the expected properties was observed. See the keyword, observed. So the Higgs boson was confirmed as a reality. No longer just hypothetical. This is important. Example number 3, gravitational waves. Henri Poincaré proposed the existence of gravitational waves way back in 1905. Einstein predicted them in 1916 based on his theory of relativity. They are extremely weak, therefore difficult to observe. Nevertheless, indirect evidence came in 1993 from observations of orbital decay. And direct observations of gravity waves were made in 2015 when a collision between two black holes was observed, there's the word, altering the length of detectors in a piece of apparatus named a LIGO, that's an acronym, in 2 laboratories in the USA. So gravitational waves were confirmed by observations. That means they were no longer just hypothetical. Please notice, none of the above hypotheses, inferences, arguments, conceptualizations, call them what you like, were taken to be good models of reality until they were confirmed by observations. Now let's look at 2 more examples. Okay, example number 4. There is extraterrestrial life somewhere outside of Earth. In this vast cosmos, we think we should find intelligent life. And that's based on statistical prior knowledge. It's the number of galaxies, the number of stars, and the number of planets, which we are now observing. Thanks to the Hubble telescope, we can now see extraterrestrial planets. And the number is utterly vast. So the chances that life has appeared on only one is ridiculous. And Frank Drake came up with an equation expressing the incredible probability of ET. Some of his factors were guesses, estimates, but nevertheless, this hypothesis, the Drake equation, was considered to be worthy of investigation. And the search for extraterrestrial intelligence, SETI, began. It started in 1960 when radio astronomy first became available. We were looking for intelligent radio signals. None have been detected yet. Here we are, 60 years later, and we haven't heard from ET. But although the proposition has not been confirmed, neither has it been denied. And so the search continues. We still think it's worthy of investigation. And it can be investigated because we know what to look for. And we know where to look, at planets, in that direction. It's a scientific hypothesis. Example number 5. There is an intelligent agent who created or designed everything. Okay, let's look at that. This hypothesis stems from mysteries. We currently have no explanations for the origin of the universe, the fine-tuning, so-called, of the universe for life, the origin of life, what consciousness actually is or how it came about, etc. We don't know yet. Science is an ongoing process. Nobody claims it's finished. And recently, the proponents of intelligent agents have turned to statistics to bolster, to substantiate their claims. But although statistics can make good arguments, all arguments need investigating for a match with observations in the natural realm. So how can we investigate example number 5, the claim that there is an intelligent agent? Well, unfortunately, the proponents of this proposition can't agree on the properties of their supposed intelligent agent. So we don't know what to look for. We did know what to look for in the case of the Higgs boson and gravity waves, and we do know what to look for in the case of extraterrestrial intelligence, but we don't know what to look for this so-called alleged God. And sometimes the proponents of this God claim that we can't observe him because he's invisible or outside of reality. That's a cop-out. Those claims do not help us to design an investigation. What sort of a detector will we make for something that's invisible, immaterial, eh? It's ridiculous. So it's not even worth trying to investigate for him, her, it. And those claims are ad hoc fallacies. In case you don't know what an ad hoc fallacy is, It's when you try to support your claim with another claim of invisibility in this case. And propositions that cannot be investigated obviously can't be confirmed or denied by observations. So they are unscientific. They are lesser than science, okay? And that makes the intelligent agent claim indistinguishable from imaginary beings like Humpty Dumpty. And using statistics to support the claim of an intelligent agent is a red herring, because statistics do not provide a link between the various mysteries and the proposed solution. They just count numbers. You can't get causality out of numbers. So that is a non sequitur fallacy. It's not coming up with any chronological link or mechanical link between the proposal and the observations that we do have. You know, that there is life, there is an earth. There's a big gap there, and that's a non sequitur fallacy. So how would we provide satisfactory verification of this claim that there is an intelligent agent? Well, only by observing it. Preferably observing it actually doing some intelligent designing. And there's lots of so-called designs in nature that are very unintelligent. But we can't do that, remember, because they claimed that you can't observe him. Back to the ad hoc fallacy. So claiming that science can't explain this, that's not evidence for your God or anyone else's God. Hey, why don't you defend other people's gods? Huh? Meanwhile, don't forget, scientists do not claim to have explanations for everything. We leave that to the religious people. And discovery is an ongoing process. It's getting faster too. We find out more quickly now than we did 200 years ago. But our ignorance is much less than it was 200 years ago. There were many more unsolved mysteries. We didn't know why the sky was blue or is blue, but we do now. And more mysteries are solved daily. So how do we do this mystery solving? Well, we start by conceptualizing possible explanations. That's stage one. And then we investigate for a match with observations in the natural realm. Remember stage two. We call this the scientific method. And it works rather well, doesn't it? Millions of people are alive today, including me, thanks to scientific discoveries. I should have died twice in my life. And there's a helicopter on Mars. This is scientific method. It's good stuff. So arguing endlessly that it's statistically probable that there is an intelligent agent behind everything is just a waste of time. And we should be spending that time looking for observations of that supposed intelligent agent. But we can't do that for the reasons given on slide 13. So, given that every mystery so far solved has turned out to have a natural explanation, Bayesian logic, he was a churchman, by the way, in the 1700s. Bayesian logic tells us that the chances of the existence of an intelligent agent are actually vanishingly improbable. And don't forget, I'm not your enemy. If you're looking to pick a fight with someone who denies your God, I'm not that person. If you're looking for someone who asserts that abiogenesis is how life originated, I'm not that man either. If you're looking for someone who asserts pangenesis is how life originated, don't look at me. If you're looking for someone who knows how the universe began, see, I don't. And the fact is that nobody knows the answers to those questions yet. So the honorable and honest position is to admit ignorance. Now, please don't waste your time straw manning me. Go and seek observations of Unkulun Kulu, or whichever hypothetical god you prefer. Yeah, thank you. That's it.